Okay, good afternoon, everybody, and welcome back to the 10th session of Sunoikisis Digital Classics Summer Term 2020. Today, our guest is William Short. He's a lecturer in the Department of Classics and Ancient History at the University of Exeter. And today we have a session about Cylleneus, this open source extensible software library written in Python that implements advanced search functionality for corpora of ancient languages, for querying text in Sanskrit, Greek, and Latin. As usual, you have a page in GitHub with the class outline, a description, resources, slides, and also other reference material. So, Bill, welcome to Sunoikisis. This is your first time in our community of Sunoikisis Digital Classics, so we are very happy to welcome you, especially for this session and for this tool. Okay, so welcome. I think you, so we can start. So I can, okay, add the slides.
Perfect.
Okay, we are ready.
Good. Well, thank you very much. Thank you, Monica, for that wonderful introduction. And good afternoon, everyone out there in cyberspace. As Monica had said, I am Bill Short, lecturer in classics at the University of Exeter. I teach Latin literature and Roman culture. And I'm going to be speaking to you today about a project I have been working on that I call Cylleneus, to build a next generation search engine. And I will we'll get into the details of what that means exactly. I should first of all thank Monica again for inviting me to participate. I'm very honored to be here, and I do want to thank all of you also for joining us, whether you're listening live or viewing the presentation after it's broadcast. So today I'm going to speak to you about a next generation corpus search engine for ancient languages, which I have been developing for about a year now, first out of my own research needs, but as I hope to show today, with some larger concerns in mind. The progression of my talk will basically be as follows. I will begin with a very broad overview of the project, explaining its key aims, its design, and a bit of its implementation. Then I will try to provide some context and motivation for my development of this search engine. And then I will dig into some of the implementation details to give you an idea of how things work under the hood. Finally, I will suggest some use cases for the search engine, and also, if possible, attempt a kind of live demonstration, which you can follow along on screen or at home, or I'll provide you also a link so you can tinker around on your own. So what is Cylleneus? Cylleneus is an advanced, feature-rich search engine for electronic corpora of ancient languages. What I mean is that Cylleneus is not in itself a standalone application for searching ancient texts. It is instead an extensible open-source software library written in Python that can provide the text search backend for any corpus-based application. Besides being highly extensible, in the sense that Cylleneus can be made to work with basically any corpus type, that it functions for Latin, and now also increasingly for Greek and even for Sanskrit, and soon perhaps also for ancient Egyptian, in the sense that it can be adapted to accommodate structured data of all sorts. But the key innovation of this search engine is that it enables text to be searched on the basis of their semantic as well as their morphosyntactic properties. This means that, for the first time, users can search for the meanings of words in ancient texts, as well as for the kinds of grammatical constructions in which they appear. In other words, Cylleneus is above all a semantic search engine, and its ability to query the meanings of words is delivered by the Sanskrit, Greek, and Latin word nets. More on that later. In fact, Cylleneus's query language is designed to take full advantage of the rich lexical and semantic information provided by the classical language word nets. Let me just emphasize this point very briefly. Cylleneus's search capabilities, in conjunction with the information provided by the word nets, Latin, Greek, and Sanskrit, permit that text can be searched by the meanings of words, as well as by the kinds of grammatical constructions they occur in. That is, it combines syntactic search capabilities with semantic search capabilities. From a kind of bird's eye view, we can say the following about Cylleneus. First, that it is intelligent, not in the sense of an artificial intelligence or a deep learning system, although it could be used to support the creation of such systems, but in the sense that it draws on the robust lexical and semantic data of the word nets, including information about lexical relations like derivation and composition, and semantic relations like antonymy, hypernymy, hyponymy, as well as domain relations, figurative relations, and so on. It delivers a highly flexible and advanced query language as well, which can combine various query types, including morphological filtering, into complex contextual or sequential phrasal searches, both for structured corpora and plain text corpora. Furthermore, Cylleneus is polyglot and speaks many languages besides Greek, Latin, and Sanskrit. In fact, relying on the multi-word net, meaning-based searches can be specified not only in English, but also in Italian, Spanish, or French. It is fast. Once a corpus has been indexed, searching is basically instantaneous, and it is extensible. With a little work, basically any corpus type can be used. Now, before getting into some of the implementation nitty-gritty, let me explain a bit more about my motivations for developing this search engine. As I will explain, my motivation comes from a practical research need that first-generation search engines were simply incapable of meeting. What I mean is this. Currently available tools for searching and browsing electronic corpora of Greek and Latin have greatly facilitated research by permitting scholars to rapidly find words or phrases within large collections of texts, and by providing annotation-rich hits automatically keyed to dictionary data and morphological analysis. These tools allow researchers to perform n-gram as well as lexical co-occurrence searches, and include the option of querying all the possible inflections of words, either through wildcard searches based on regular expression matching, or through lemma-based searches if a corpus is annotated and supports that functionality. Such capabilities have made Corpus Search extremely effectual for morphologically complex languages like Greek and Latin, where before researchers had to conduct laborious searches by hand or rely on printed concordances, providing limited contextualization and sometimes spotty coverage. However, most of these tools were designed exclusively for word form queries and cannot accommodate grammatical specifications as search parameters. Some tools do, of course, permit searching by word syntactic roles and dependency relations. And I'll just point out, so I've just put on the screen there on this slide some of the functionality that I would say characterizes first-gen search tools, obviously word form searches, wildcard searches, and lemma searches. There are also special cases, special corpus types. For example, the Tesserae project out of Buffalo is focused on intertextual searches between texts, even across languages. And Pedicerto is focused on metrical pattern searches. So these different corpora have obviously different concerns as special cases. I'll point out just also one interface for searching tree banks, so searching syntactic relations, dependency relations. This is an experimental and I would say quite user-unfriendly, at least so far, interface that's available for searching the syntactic information of the ancient Greek and Latin dependency tree rank. But these, besides being experimental, these are usually for quite limited corpora, and they require learning abstruse query languages. If you look in the upper left-hand corner of the slide, you'll see the ANISQL query for this is the genitive case of the Latin word virtus. Case equals genitive and lemma equals, so anyway, you can see that the query builder, the query is specified in a quite abstruse form. Now, most problematically for my purposes, although computational semantic search has been explored, no corpus and no service yet exists that permits users to query meanings either in Greek or in Latin. Nor has any taken advantage of the precision that a lexical database could afford. An opportunity thus remains for next-generation technologies capable of redefining the kinds of questions that can be asked of our corpora. Now, this state of affairs in corpus-based tooling presents a major problem, a very serious bottleneck, in fact, for the kind of research that I personally do. Just very briefly, my research aims to reconstruct so-called cultural metaphors from linguistic and literary evidence. Different from what Paul Ricoeur termed lively metaphor, cultural metaphors are those that are highly conventionalized across different authors and genres, different temporal periods, and different levels of linguistic encoding, and which function as a language speakers automatically relied upon conceptual models. Let me give you an example. In Tacitus's histories, we can find the expression flagrabat ingens bellum, which we can translate as a huge war was burning, or in English we might say a huge war was raging, using a somewhat different metaphor. An immediate question emerges in my kind of research when encountering a metaphorical expression of this kind. Is this image of war burning a creation of Tacitus's authorial imagination, or is it a more conventionalized, more regular way of expressing the idea of the intensity of war in Latin? Conceptual metaphor theory suggests that figurative relations like this are part of everyday language and thought, rather than merely creative inventions. But to get an accurate picture of the mappings involved in a figurative expression like this, and to determine whether this is merely a one-off literary formulation or the manifestation of a more generalized conceptual mapping, more widespread throughout the language, implies searching for the whole range of lexemes that pertain to war and to fire, since cognitive linguistics posits that metaphorical relations hold between systems of concepts rather than individual lexical items. With available corpus search tools, this represents a serious bottleneck. Assuming a source domain vocabulary of adolere, aduro, aistuare, ardere, fervere, flagrare, incendere, torrere, and so on. Okay, you can think about all of the words in Latin all of the verbs in Latin in this case that could mean something like burn, be on fire. And a target domain vocabulary of bellum, certatus, certamen, colluctatio, concertatio, conflictus, congressio, congressus, dimicatio, prolium, pugna, and even Mars, okay, all of the words, or some of the words in Latin that have to do with war, or that directly mean war, you would have to perform at least 255 discrete queries to capture combinations, all possible combinations of those lexical fields. And that would just be for two-word phrases, not even beginning to cover this metaphor. Basically, you would be stuck in front of a computer screen for the rest of your life just to study a very simple linguistic expression. Consider as another example that the Latin word locus, literally a place, can be used metaphorically in the sense of an idea. As for instance, in Cicero's per purgatus est is locus a nobis quinque libris. Obviously, he's not speaking literally about a place. He means I have treated that idea in 5 books. So the word has a markedly metaphorical sense. The same metaphor can also be detected in many other expressions in Latin, such as concilium in ire, venire ad notionem, cadere in cogitationem, and sententiae cadere. The constructions in each case are different, the vocabulary in each case is different, but the metaphor in each case is the same. In all of these examples, different kinds of mental operations, formulating plans, agreeing with opinions, considering ideas, conceiving notions, are conveyed figuratively as movement toward a location, right? To enter into a plan, concilium inire, to come, literally, to come to a notion, to fall into a thought, to approach an opinion. They're conveyed literally as movement toward a location, entering, coming to, falling into, approaching, and so on. With existing tools, discovering such patterns of metaphorical structure requires painstakingly searching the corpus for every possible combination of these motion verbs, with some noun denoting a mental category. A tool that allows searching for any word meaning enter, come, fall, approach, or even better, for the broad category of motion toward, in conjunction with the semantic field of thought, the lexical field denoting thought, would instead make this metaphor identification task trivial. Or consider the famous phrase of Virgil, mihi frigidus horror membra quatit, cold fear shakes my limbs, from the Aeneid, spoken by Aeneas as he recounts the portent of the bleeding tree. In this image, in which fear, horror, is metaphorically cold and shakes the body, is this image an invention of Virgil's poetic imagination? A lexical co-occurrence search seems to suggest so. The pairing frigidus horror occurs only twice elsewhere in Latin literature. In Lucretius's Validi ferri natura et frigidus horror, the nature and cold stiffness of strong iron, which likely served as a model for the Virgilian line, but where horror preserves its more literal sense. And in Ovid's Nunc quoque frigidus artus, dum loquor horror habet. Now cold fear takes hold of my limbs as I speak. You can see the examples on the slide, which shares the sense of Virgil's phrase and was in fact likely influenced by it. Yet a search for all words that share the sense of horror, you can think of metus, timor, timiditas, pavor, formido, and probably others, in conjunction with words meaning cold or shivering, frigidus, the adjective, but also frigor, gelidus, gelu, horridus, tremor, quatio, and probably many others, reveals that representations of fear in such metaphorical terms are in fact widespread in the language and quite conventional across different authors, genres, and time periods. Whereas this kind of linguistic fact could easily be obscured by traditional methods of corpus search, a search engine capable of parameterizing word sense could help ground findings empirically. What research like this requires is a tool that moves corpus-based methodologies beyond brute force word form, or even lemma-based search, to include queries that can also incorporate meanings, concepts, and syntax as search parameters. Indeed, to be truly effective for my kind of research, in conjunction with semantic queries, a tool also needs to accommodate queries based on the grammatical properties of words, okay, civitas in the dative case, but also bare morphosyntactic configurations. Okay. Any word in the accusative plural, for example, or a verb. That is, it will have to enable searching text for constructions independent of any lexical elements that happen to instantiate them. When combined with meaning-based queries, this kind of search could have a significant impact on the study of ancient languages, whose grammatical systems abound in highly complex and very often multiple seemingly functional equivalent syntactic constructions. In particular, and closest to home in my case, it could propel new studies in the growing field of cognitive classical linguistics, which treats constructions as having meanings in and of themselves, separate from the meanings of the words of which they are composed. Well, I like to think that Cylleneus delivers exactly this. But I want to address the question of how, more precisely, it can do this. So now let me turn to some of the details of the implementation of the search engine. And in the very first place, to speak about the implementation of meaning-based queries. To enable queries that include specifications about the meanings of words, and in fact, not only their senses, but also their semantic relations, Cylleneus takes advantage of the Sanskrit, Ancient Greek, and Latin word nets. I should say that other methods of implementing semantic search have been tried, I'm afraid largely unsuccessfully. One way of doing so has been to try to overlay lexical translation on traditional corpus search methodologies. So under such a model, semantic processing would happen at the front end of searches, but more or less based on bilingual dictionaries, translation dictionaries, and is independent of the text themselves, so to speak. The user would give, for example, an English meaning as part of the search parameters. Say, for example, find all occurrences of home in Ovid's Tristia. Obviously, you would get a lot of results for that. And the search engine would then query an English to Latin lexicon in order to translate this meaning into a set of potential target language words: domos, domicilium, aides, perhaps also villa, casa, tugurium, tectum, and even insula. The search is then conducted as a battery of queries using the generated set of terms. But this methodology has several severe shortcomings. It requires the set of query terms to be computed anew at each search, even if a Latin query set for a given English meaning can be cached in some way. More problematically, it requires searching the same text again for every lemma in the query set, increasing exponentially for multiple meaning queries. So how about return home? Moreover, it risks missing contexts where the specified meaning is instantiated linguistically in ways not captured by the dictionary. The WordNet framework, by contrast, provides a robust lexicosemantic backend to Cylleneus's corpus search capabilities. Very briefly, in a WordNet, lexemes, and to a lesser extent phrasal lexical items, are assigned to one or more synsets, which correspond to its various senses. You can think of synsets as the definitions of words or as concepts, which words denote. Each synset can therefore be seen as constituting a set of semantically related words. That's why they're called synsets, synonym sets. For example, the synset glossed as an individual building where a person resides, home, includes, as it were, the English words house and home. Home is also included in the synset glossed as a place of emotional attachment where one resides, thus capturing this word's specific semantic features and differentiating it from house. I should also say each of these synsets is given a unique identification number or unique identification string. And this is a point that we'll come back to a little bit later. A WordNet can also include information about semantic relations between synsets, such as antonymy, hypernymy, and holonymy, as well as lexical relations of different kinds. Synsets may also be grouped into broader semantic fields or conceptual domains called SEM fields. In the WordNets of the classical languages, words from Sanskrit, Greek, and Latin are keyed to a single pool of synset identification numbers where appropriate. Thus, in the Latin WordNet, domus and domicilium are tagged with the same synset identifier as house and home are in the English WordNet, just as oikos in the Greek WordNet and niketa in Sanskrit are, to the extent that the meanings of these terms overlap. Of course, as the senses of words in these languages are often idiosyncratic, the WordNets also include many language-specific synsets in order to model the semantic system of each individual language as accurately as possible. Just to try to give you a better picture of what we're talking about, we can briefly consider the semantic network of Latin arrow as encoded in the Latin WordNet, or at least a small part of it. The lemma entry for arrow in the WordNet specifies a large amount of lexical and morphological information, including its principal parts, its phonological structure, its morphological characteristics. And data structures are also available for encoding its etymological relations and senses, diachronic and generic information relating to its meanings. Then, of course, its meanings are recorded as represented by synsets. Here you can see each of the synsets, although only their glosses are given. Arrow's literal sense of wandering, okay, to wander about aimlessly. Its figurative sense of making a mistake, and so on as its different branches, as well as other lemmas in the database, which share those same senses, those same synsets with this word. So, for example, wagor can also mean to wander about aimlessly, but wagor has its own semantic structure. It can mean to be subject to change, which is only a very, very peripheral meaning of arrow, though the two words share the idea, the figurative sense of turning one's attention away from a topic. And you can trace the semantic pathways of arrow in different directions. So its figurative sense of mistaking, that can be narrowed to speech errors. So to speak incorrectly, that is also a meaning of the word delinquo, although in most respects, arrow and delinquo do not overlap in their semantic structure. In this one sense, they do happen to. So you can see the semantic relations branching out, semantic and lexical relations branching out in a very ramified fashion. And naturally, these branches could be traced much further, giving a view of the whole lexical and semantic field in which arrow participates by virtue of its different literal, metonymic, and metaphorical meanings. And we've only considered just a couple of those on this slide. I've spoken here about the Latin WordNet specifically, which is an ongoing project based at the University of Exeter in collaboration with an international team of scholars. But it has sister WordNets, so to speak, in the ancient Greek WordNet based at Harvard's Center for Hellenic Studies, which is being developed jointly by the CHS, Exeter, and the University of Pavia. Likewise, the Sanskrit WordNet, housed in Pavia, is curated by a team coordinated between these institutions. The three WordNets share the same basic design and architecture, and are so fully interoperable and present a unified API. And I've given the URLs there for the three sites, as well as just one indication. This is the number of lemmas, more or less, that each of the WordNets currently contains. All of them are undergoing curation. And so as time goes on, they are improved in terms of how they represent the semantic structures of their respective languages. And I want to highlight just some of the features. I've already mentioned some, but some of the features of the ancient language WordNets. And one critical innovation over the Princeton, that is English WordNet framework, has been our introduction of discriminations between words' literal, metonymic, and metaphoric senses. Whereas the original WordNet specification treats semantic structure as basically flat, so whether a sense is a figurative sense or a literal sense, they're treated all the same. We recognize in the ancient language WordNets the importance of figurative relations, both at the level of word sense organization. So a word's senses can be tagged as either a literal, metonymic, or metaphoric sense, and at the level of the overall organization of the semantic system in terms of supralexical, metaphorical, and metonymic mappings. Basing Cylleneus's semantic capabilities on WordNet data structures thus opens up powerful capabilities. By indexing the text of ancient language corpora, tagging each token with its relevant synsets, its relevant meanings, Cylleneus avoids the bottleneck and potential gaps in translation methods which use an intermediate bilingual lexicon. While meanings specified by the user as search parameters need to be converted to synset identifiers, this can be done automatically and efficiently. Conceivably, a user could conduct searches using synset identification numbers directly, but translating terms specified in English or some other language to their synset equivalents, or even searching for synsets based on their glosses, entails almost no performance cost. Most importantly, search parameters can include specifications based on semantic and lexical relations. Thus, a user could search for only the antonyms of a specific word or word meaning, or search for the hyponyms of a semantically superordinate term, or query the corpus for the derivatives of some given lemma. Cylleneus also accommodates queries based on semantic fields, the so-called SEM fields, which I mentioned before, enabling very broad searches over large sets of semantically related categories of terms or conceptual domains. So, for example, economy, military, architecture, anatomy. To deliver the necessary granularity of conceptual domains, the ancient language WordNets use the Dewey Decimal Classification System as a topic index. Although this classification system obviously includes many domains that are largely irrelevant to ancient texts, like the history of South America, for instance, or extraterrestrial worlds, although there are actually texts in Greek and Latin where you can imagine those domains occurring. It provides suitably discrete category distinctions in areas like Greek and Roman religion, Latin literature, philosophy, geography of the ancient world. So it functions as a quite robust and very comprehensive topic index. Now, obviously, searching for a semantic domain like anatomy in the text of Galen or architecture in the text of Vitruvius is going to produce very many matches, probably too many to be actually useful. But this kind of broad semantic field query, combined with more refined queries, allows searches at different levels of conceptual abstraction. Furthermore, as synsets are common to the vocabularies of many different languages within the multi-word net, it's possible for a user to specify as search parameters meanings in any one of the languages covered by this framework. In being based on synset identification numbers, rather than lemma forms or word definitions in English, Cylleneus is in fact conceivably able to handle searches in multiple different languages simultaneously. By incorporating WordNet constructs, Cylleneus can bring other improvements to Corpus Search as well. Because queries are conducted over synset identification numbers, which represent the discrete senses of words, the search engine will make it possible to perform highly specific semantic queries. When improved over time through manual verification, and especially when conjoined with semantically annotated corpora, that is, SEM banks, paralleling tree banks, syntactically annotated corpora, Cylleneus will deliver extremely accurate and refined corpus search results. The possibility of integrating Cylleneus with a database of semantically annotated texts answers any objection, moreover, that by automatically assigning senses to the words in a corpus, we are somehow predetermining, in the sense of limiting, the meaning of ancient texts. Of course, for many words occurring in our corpora, it is possible to assign one and only one synset identifier that accurately represents that word's sense in context. On the other hand, establishing the exact sense of a word in context is sometimes difficult, perhaps impossible, due to textual problems arising from the transmission process, intentional or unintentional lexical ambiguities, or disagreements of interpretation in literary analysis. For this reason, a parallel project that we call the Ancient Greek and Latin Sembank is now being launched to provide semantically annotated texts, beginning with markup of the Homeric hymn to Demeter and the poems of Catullus, in order to empower Cylleneus with manually verified semantic markup, using a markup specification that accommodates semantic annotation at the lemma and the phrase level, as well as multiple sense determinations, where legitimate textual or interpretive ambiguities might exist. In this way, the Sembank and Cylleneus will recognize that literary texts are generally open to having various meanings. And I've put up just on the screen there, oops, let me go back for 1 second. I've put up on the screen a single phrase from Cato's De Agricultura, just to show you the simple idea, in a sense, behind the Sembank. This is just to annotate the words in the corpus with the relevant, contextually relevant synsets. So they specify the sense in context of the words here. I now want to get into some of the details of implementation, beginning with the types of queries that Cylleneus enables for corpora. Here I have listed the basic query types and the admittedly still quite abstruse query language for constructing searches. I should say, incidentally, we're now working with Alessandro Vatri, the curator of the Dioresis corpus, to implement a more intuitive natural language method for constructing queries that will be corpus agnostic, but also take advantage of the different kind of query types that different systems and different corpora afford. So Cylleneus can, of course, handle many of the kinds of queries that we would expect from any corpus search system. Word form queries matching literal strings, wildcard queries matching partial strings, lemma-based queries matching any form of a given lemma. In addition, however, Cylleneus can handle meaning-based queries specified in several languages. So in the examples that I've given here on the slide, the user is searching for any lemma that matches in meaning to the English term courage. That's what English courage is specifying there, or the Italian word guerra. Specific synsets can also be given, though that's probably less useful for most users, but maybe helpful for programmatic interactions as search terms, or synsets can be resolved from their glosses. Semfield queries will search for all synsets belonging to a particular semantic domain. The examples that I've given there, okay, 611, that is the Dewey Decimal number for anatomy. You can also search for, you can also search in the English descriptors of the Dewey Decimal categories to resolve to the correct SEM fields. Queries can also be specified according to lexical and semantic relations of different kinds. For instance, the The forward slash there in front of bellum denotes a generic lexical relation. Think of the relation between bellum and bellicosus, or bellator, or bellatrix. So that will find all lemmas related to bellum, at least so far as they're encoded in the WordNet at this point. The exclamation mark indicates an antonymy. So the example given here will find words whose meanings corresponds to the antonym of English courage, something like cowardice. Morphological queries are probably self-explanatory, but these can be of two different kinds. You can provide as search parameters just bald morphological tags expressed in Leipzig annotation, and those will find any word conforming to the specified description. In the example here, all accusative plurals. Or such tags can be used as filters on other kinds of queries. So on semfield queries, on meaning-based queries, or on lemma queries. For instance, only ablative singular forms of those words whose meaning matches English courage in the example that I've given there. Finally, for corpora which contain morphosyntactic annotations, like the Proyel corpus or the Laszlo corpus, Cylleneus provides a specialized query type. Of course, all of these different kinds of queries can be combined into more complex ones. For example, strictly sequential adjacency queries can be specified by including one or more query descriptors within double quotes, whereas leaving out the quotes would mean that the descriptors will be matched just if they occur in the same context. Just continuing to talk at a more detailed level of implementation, something that may be of interest to us here, I'd like to touch quickly on one important detail, that is its usage of indexes to improve the efficiency and scope of Corpus Search. Now, many search engines operate directly on Corpus source files, whether these are JSON files or XML files or some other format. While this means that applications can be quite lightweight, do not require additional infrastructure, it also means that they can be fairly limited to a certain descriptive format and cannot easily accommodate source texts of different kinds, that is, from different corpora. It also means that searches are often quite slow or limited to certain technologies, like regular expression matching or XPath queries. Furthermore, some corpora are proprietary and have very restrictive licensing on the distribution of source files. Cylleneus avoids this by implementing its own indexes and not storing text at all in those indexes. On the other hand, the fact that Cylleneus, which is based on the Python library Whoosh, which is itself an Apache Lucene derivative, it makes use of indexes, and this means that that any changes to the source file, so this is on balance, any changes to the source files or large-scale improvements to the underlying word nets will require time-consuming and resource-consuming re-indexing. But that's the trade-off that we have chosen to adapt to. Fortunately, the indexing pipeline does not demand that corpora be indexed wholesale. This can be done piecemeal and on a rolling basis. I've mentioned indexes, so I want to talk a bit about the indexing pipeline, what that comprises. It's fairly straightforward. It depends to a large degree on the annotation structure of the corpus in question and the availability of different kinds of data, and will therefore include some different steps. At the heart of the indexing process is the document schema, which specifies the searchable fields of documents in the corpus. For instance, all corpora will support form searches, word form searches, but only corpora with the appropriate annotations will support something like the morphosyntax queries with their own special query specification, form of query specification. The document schema also stores additional metadata, for example, author, title, translator, date, or some kind of generic information. So the schema thus provides an interface between the raw source files of the corpus and the rest of the indexing pipeline, and ultimately the query language. Once the data of a source file has been read in, it's passed, as we would probably expect, to a tokenizer custom made for a particular corpus, again, depending on the format of the source files. And once a text has been tokenized, the tokens are handed off to a lemma filter, which in the absence of lemmatization in the source files can perform its own, relying on the relevant wordnet for the language of the source text. Once tokens have been transformed into a stream of lemmas, then synset information is pulled from the wordnet by the synset filter and the semfield filter, while the morphology filter associates tokens with morphological information, and the morphosyntax filter can assign syntactic annotations. And any other bespoke filters can be written to bring in the kinds of information that a corpus might provide to form part of the query system. So even, for example, metrical annotations could be fed in, and some kind of metrical query specification could be built, and then metrical searches could be performed in conjunction with the semantic searches of the different kinds. For example, the ancient Greek and Latin sembank will include metaphorical information. It will include figurative information. So queries about metaphorical and metonymic relations can be queried directly. The other piece of necessary infrastructure for integrating a corpus into Cylleneus is some kind of fetch function, as I mentioned before. The indexes do not directly store the source text. They store referencing information to a source text. And so as Cylleneus does not maintain itself the display text in the index, this kind of function is required if you then want Cylleneus to be able to fetch the text from the original source files for display to the user. Obviously, that depends on a particular use case. If displaying the text is the end point of a particular application. And if no fetch function is available, then only the raw reference citations will be usable. As I have mentioned, Cylleneus is flexible enough to work with basically any corpus type, and infrastructure is already available for working with the corpora that I've listed here. And it's in fact easy to create an indexing pipeline for any other corpus, especially, I should say, by reusing code that has already been written. It can be modified slightly to adapt to the structure of another corpus type. As you can see, Latin is more robustly represented than either Greek or Sanskrit. That's largely due to my own interests, also to the progression of the Latin wordnet, and generally to the ease, I should say, of dealing with Latin data as compared to the other languages, as I'm sure many of you will understand. However, work is now quickening to bring Greek and Sanskrit onto par with Latin. For instance, prototype infrastructure is already available for querying the digital corpus of Sanskrit, a semantically annotated corpus of Sanskrit, and for indexing and searching the diaeresis Greek corpus that I had occasion to mention before. Now, just to wrap up kind of quickly, in addition to my own research, I just want to suggest some things. It's pretty easy to envisage the usage of Cylleneus to conduct various kinds of study. In fact, Cylleneus is already being used in translation research and is being experimented with in intertextual research. And on the slide there, if you have access just to the PDF, I will post The links that are on the slide, these are links to 2 sample Jupyter notebooks, which exemplify this kind of work and which are available for you to play with in the cloud. And in fact, I would like to demonstrate, I think with the remaining time, if I can take just a moment, I can give just a brief demonstration simply to show you some live running code, and okay, crossing fingers that it all works. If you like, either now or later, you're free to use this link to bring up the Jupyter notebook. I will switch screens here if I can, and let's see, and pray. If I can just bring up the notebook running with in the binder service. Let's see how it goes. This is the binder service here. It's just loading up or should be loading up the notebook. It's a bit finicky, but once we get it going, we should be able to see the code. And I show this to you I know that most of you in the audience are probably comfortable with the code in the notebook. I just show it's a more manageable interface than cloning the repository and installing the search engine that way. We also have, you'll see on GitHub, a quite rudimentary web app, but it offers much of the same functionality. And if you prefer that, you can also install that. But here you can see this is just one way which you could use the search.
Bill, I think because we still see your slides, I think you have to share again your screen, entire screen, so that we can see the browser. And
that's perfect. Okay, no, that's great. So I'm going to stop and share again. No, thank you there.
No, don't worry. And we have time, so no rush.
That's great. Perfect. That's good. Then you won't actually see the nuts and bolts of the binder loading up there. So now you should be able to see a Jupyter notebook. Yeah. Okay. Good.
Yes. Now we see it.
Okay, that's perfect. So this is just running in this binder service, running in the cloud. But we've got just some very basic. This is in Python, as you see. Just some very basic setup here. I'm just going to click on that to get it going. We're just doing a couple of things. You can see there from the Cylleneus package, we're importing the main entry points to search. So corpus, collection. A collection is just a collection of texts that will be involved in a search. Those can be texts from different corpora, in fact. So you don't have to, once you choose a corpus, you can mix and match texts from different corpora within a single search, provided, of course, that they all support the same kinds of queries. I'm also just making sure here that the multi-word net is all in place so that we can try some queries in different languages if we like. I can show you I have some sample corpora, very, very small mini corpora that are available on GitHub, just to represent the different languages. As you can see, mostly Latin, but also the digital corpus of Sanskrit, a couple of texts from each of these corpora, just to experiment with, just for testing and experimentation. So then you need to, of course, instantiate a corpus type. Let's see, I don't know, just for fun, let's do proel. You can bring that up. It will download the repository, the sample corpus, if it's not already on your machine. Obviously, since this is running in the cloud, it has done that. We can list the works in the corpus. There we go. So the De Officiis of Cicero. And what I'll do here is just say, okay, it's only one text anyway. So we'll just say the whole corpus will be our search collection. Here I've just given some of the basic query types. Okay, so form searches, lemma searches, concept, that is meaning-based searches, semfield searches, and morphology searches, whether this kind of bold sort search or filtered search. And then we can build a query. And actually, let's just try, just to show you what we're talking about, we can try a meaning-based search. Let's try English courage. Okay. Here we have some code. This is just to display the text nicely. This just runs the search and then prints out the search results. And let's see what happens. All right, here we go. So we have some results of this meaning-based search, right? So we're searching for any word, in fact, any form of any word that corresponds to the meaning of English courage. And let's see what we've got. All right, in Cicero's De Officiis, we have virtute. That's very nice. Virtus obviously means that. Animus. Okay, so we've got animus in genitive case in one instance. In the ablative case, we didn't specify a case. There's animus again. Animos, animus. Okay, Cicero obviously likes animus. But here we go. We've got animus in one instance and robore in another. We know that robor can mean courage or strength metaphorically. That's very nice. Virtus again, virtus, animus, and so on and so forth. So you can, mens. Yeah, mens can mean courage in certain cases. So you can see we've done a search that is abstracted away from the level of the lemma, right? We're not just searching for virtus or animus. We're searching for any lemma at all that corresponds in meaning, and indeed any form of any lemma that corresponds in meaning to that English word. So that's quite a powerful thing, I think, for well, in the first place, for example, students, those without expert knowledge of the language. It can open up tech. It can open up ancient text to more students, perhaps, and obviously for research of the kind that I undertake, where I'm less interested in the specific lexical instantiation of a metaphor as I am in the relationship between concepts. Of course, you can do form and lemma searches as well. We can try, let's see here, let's try the anatomy. This is the semfield search. We're just going to search for semfields that correspond to anatomy. Let's try that. I have no idea. Whoop. That's embarrassing, but that's fine. Okay. That's not, let's try that. Here we go. That's just a mistake in the query parsing. Let's see. Now, since we're doing a semfield search here, you can imagine this is going to produce a very large number of results because we're talking about a huge collection of synsets. So not just a particular set of lemmas, but any lemma that matches any of the synsets within the anatomy domain. And well, sometimes the results are quite fuzzy. Sometimes they're very interesting. So you can search here. It has found liber. I think that's probably the bark meaning of liber. Pars, as in the part of a body. Solam. So you can see at a very, very high level of abstraction, and some of the fuzziness here in the search is, of course, due to words in the WordNet which have not yet undergone curation, which may have extraneous sense attributions. Certainly eudicio, I would not expect in the anatomy domain. But you can see how it works, that we're operating now at a very, very abstract level of sense relations, which can also be a quite powerful way of searching texts. And since I'm it looks like I'm bumping up right against time. I can leave you with that. As I said, this Jupyter notebook is running in the cloud. It's there at the link that I've provided. If you can't access that link, I can give it to you again. You're free to play around with that. In fact, I would invite you to do so, to put the search engine through its paces. It's a project that is well on its way, but still requires a lot of work. And the more people that we have looking at it, the better. That's probably true in all cases. It's certainly true. It's certainly true for us. So I can end there. And Monica, I think we can move to questions if anybody has them. I'm happy to take questions or comments or anything.
Okay, thank you very much for this great presentation. Yes, we have many interesting things, and especially in the last part, and when we can see really examples. So we have people in StreamYard, but we also have an audience on YouTube. So please ask questions. We can open the discussion.
I have a very quick question, if I may. This may just be I missed something in your presentation, but when you gave the list of the corpora that you're currently able to query using Cylleneus, are they all corpora that are syntactically and semantically annotated already, or are some of them plain text corpora?
No, some of them are, well, none of them, I should say, are semantically annotated. Some of them are syntactically annotated. So, for example, the tree banks can be fed in. That could be one corpus. LASLA, for example, contains some morphosyntactic annotations. They're all actually at different, well, they have different sets of annotations, and some of them are indeed plain text corpora with no annotations. And in a case like that, we are relying exclusively on the WordNet, for example, for lemmatization. So all of the lemmatization would be performed by the WordNet API, rather than relying on a more curated, verified lemmatization process that some corpora might offer. So the corpus that you're working with will afford different levels of, will in the first case afford different kinds of queries, right? So a syntactically annotated corpus will allow you to do those morphosyntactic searches, where a plain text corpus just won't, because we don't have that kind of information. You can do morphological searches on a plain text corpus, because through lemmatization, we can also gather morphological information, right? So the short answer is, it really just depends on the corpus you're working with, what level of, what number of query types you're able to perform. Great question.
So, related question. Thank you. Following on from that, how difficult is it then to add a new, if you of one of the plain text corpora, for example, to add a new corpus to corpora that you're able to query? So how difficult would it be to add Picardo info, for example, as corpus, or PHI as an corpus?
Yeah, I mean, a plain text corpus is pretty easy, because all of the filters, once you get past the stage of tokenization, if we're talking about a plain text corpus, all of the default already built lemma filters, synset filters would be fine. So that could be done in an afternoon. You could probably add, really all you have to do is build a tokenizer that will read in the text, tag the text, provide some way of fetching the text back. So that means tracking, word position and so forth and so on. But it's also true that, since we already have a lot of the infrastructure for these corpora built, a new corpus that is of just a slightly different format is quite easy to integrate it. So I'll just give you as an example. I have just recently integrated the Diaeresis Greek corpus in, I think over the course of about a day and a half. With kids at home, I was able to build the infrastructure to do that. So, okay, yes, of course, I have experience doing this, but with some guidance and looking at the code that we already have, it's really not very difficult.
Yeah. I have a related question about that. So with a plain text corpus, in your experience, do you have an idea of the amount of lemma that we can get from WordNet? Roughly, of course, in the sense that you said that with the plain text corpus, you use the lemmatization through WordNet. For Greek, Latin, I don't know.
Yes. So how much coverage would we offer? So the WordNet has a little over 70,000 lemmas in it. So, and that covers archaic through some medieval lemmas. So the coverage is pretty good. No, of course you won't get everything. And if you have a plain text corpus, that hasn't been curated at all, so spelling variations are at this stage something that we wouldn't handle very well. So yes, you're right that a plain text corpus will offer some challenges, but the coverage in the Latin WordNet and the other WordNets is quite good. Now I should say for the Sanskrit WordNet, that is based on the digital corpus of Sanskrit, so it would offer basically full coverage of the Sanskrit texts that are in that corpus. And I just don't. Since I'm not a Sanskritist, I don't personally know what that represents in terms of the overall Sanskrit corpus. But I would be pretty confident that the Sanskrit and the Greek WordNets have very good lemma coverage. Yep.
Okay, thank you.
Yeah, thank you. Great question.
Other questions? So we have a comment and a question in the chat. I don't know if you can read the chat still on the right. So Anise from Brazil is a colleague working on Greek linguistics.
Yep, I see. So, okay, the question is, it's in two parts. So the first question is, multi-WordNet doesn't have Portuguese. I think it does, actually. So it would be very easy to integrate Portuguese into it. I believe it does exist, actually. And yeah, and actually it would be easy enough to do the work ourselves of bringing Portuguese into the framework, and then being able to search in Portuguese. So that's a tentative yes, I would say, positive response. What would I have to do to have index translation alignments Greek to Portuguese? So I have built, again, a quite experimental translation alignment corpus for it's for Homer, so for Greek. Again, based on that, it wouldn't be difficult to you need the parallel texts, and then you need some you need query types. You need to build a system for bringing the parallel text together, more or less. So Cylleneus, of course, can handle the indexing, and then you just need something that says, okay, I want to, what is my query going to look like, comparing or using the two texts in parallel. Yeah, that's so perfect. What was the hardest part of building Cylleneus? Well, I should say, apart from the work of the WordNets, which is ongoing and massive, the hardest part of building the system in itself was getting, so it's, as I mentioned before, it's built on this whoosh Python library. This was a kind of generic but very flexible search engine library, but it was designed not really to work at the level of of a particular line or of a particular section. So what this search engine offered was, you give it a query and it will just tell you what documents a word matches in. But of course, that's not good enough for the kind of queries that we're interested in doing. Whereas we want the specific, we need to find a specific line, a specific word, the exact referencing information for that. So I think the hardest part overall was to redesign this search engine to accommodate pinpoint searches. And the second thing in combination with that has been the hardest part. Well, one of the hardest things has been to do the morphological filtering and to make it efficient. So to take a query type and then to overlay or filter it through a morphological query, that I was up very many late nights trying to figure that problem out. So.
Other questions?
I have a curiosity. How efficient do you think it would be on epigraphic sources?
Yeah, well, with epigraphic sources, we might run into a problem. Sorry, say it again?
I mean, epigraphic sources in Greek, Latin, not necessarily hieroglyphs or very complicated.
Yeah. Yeah. No, of course. Yeah, it could, it will certainly work with them. I think one of the problems you might encounter is if you have a text that, for example, is fragmentary, then you're going to run into problems where if it can't latch on to a token, a lemma, it's not going to have any success. But provided that the text is in decent shape and that the WordNet has those words in it, no problem. Again, it's just a question of how do we feed the data into Cylleneus, but then all of the query types would be available to us. So that would be a fun project to undertake.
Yeah, I suppose
in Greek in particular, you'd also have the issue of dialects.
Yeah, dialect.
Spelling, and all things like that, which makes lemmatization
exactly. Yeah, exactly.
3 times as hard.
Yeah, no, that's exactly right. And dialect is one of the things for the Greek WordNet that we are thinking a lot about, and how can we build in dialect variation into the lemma record so that it's all linked together. And the problems that we all encounter. Of course, we're not.
Ambiguity, of course, right? Because you can say, I'm going to capture all the possible dialect forms of this word, but you've then suddenly introduced ambiguity with a different form of a complete different lemma.
Exactly. Yeah. Right. No, that's exactly right. Yeah. Good. Thank you.
Yeah, and definitely in this case, of course, we missed that, or at least we have been discussing a lot about annotating inscriptions. We missed that in that case, and then, as you mentioned, with fragmentary inscriptions where we have ambiguities in the text, of course, we have problems. We tried tree-banking inscriptions, but there are problems at a morphological and syntactic level. For papyri, we have now linguistic annotations. Maria Vierres definitely is working a lot in this sense. So maybe in the future, we can also experiment with this. Of course, the language of inscriptions and documentary papyri in this case is different from literary text, of course. So, but anyway, we have a lot of work for the future. No, there is work for generations.
Yeah, indeed. For generations, no problem there. Yeah, but you're absolutely right. That is, if we had access to those, to some structure, to an annotated corpus. Once you have an annotated corpus, that's the gold standard, right? Then we're home free basically, and we can implement it as we like, dealing with dealing with a plain text corpus is easy on one hand, because you can just read it in and not worry about anything, but it's difficult, of course, because you encounter all of these other problems, and your information is fuzzy at that point.
Okay, we have 1 minute, maybe last question. You may, and then you are free. So you mentioned that you use the per se translation alignment corpus. Maybe I missed something in your presentation. How did you use that corpus in the sense for translation alignment? Because we have been working a lot also in Leipzig for translation alignment. So of course you use the alignment to get more information. Can you say something more about that?
Yeah.
Also because we have students working with translation alignment.
Yeah.
So just to have. Yeah.
No. That's great. And what I can do actually is, am I able to paste a link into?
Yes, you can paste it in the comments. So also people on YouTube can see your link.
Okay, let's see if I can. I'm gonna have to. I'm sorry. I'm gonna have to do it into the private chat, and then if you wouldn't mind.
Okay. Yes.
Sorry,
Yeah.
I just can't see. Okay, so I have another.
Okay.
And then if you could just transfer it over, that would be great.
Yeah, of course.
Yeah, so what I have done so far with the translation alignment corpus is I just have the infrastructure there that indexes both languages, right? The text of both languages. So if you have, for the source file in Greek, the alignment file in English, right? Or you have the alignments marked up, then it reads those in. And then you can perform queries as you like on them. So there's no specific query type for translation alignments. This is a way in which, for different kinds of research, Cylleneus is not going to predetermine the kind of work that can be done with the text. It is going to provide a query framework that could then be implemented to undertake different kinds of research. So you'll see in the notebook that I've provided there, the link that I've provided there, this is just a kind of experiment that I undertook to see, well, how can we play with texts that we're able to search with parallel texts that we're now able to search with Cylleneus. So relying on bringing them together, we can search the English text and compare them precisely to at the level of the alignment to our Greek text. You could conceivably build a kind of query where you search, for example, for a Greek or a Latin phrase, and instead of searching, it would first search the original language text, gather the references, and then spit out the results from the translation alignment. So you could actually build a query type, right, that sort of reverse engineers the query itself. Given you search for bellum, and it finds those examples of bellum in the Latin text, but instead it gives you the results for the parallel English alignment. I don't know. I mean, this is a way in which, just because this is not really an area of research that I have much experience in, the kinds of questions we might ask of translation alignments, I don't know very well. But I think Cylleneus can provide an infrastructure for helping to answer those kinds of questions. So I encourage you just to play around with that notebook, and if it's interesting at all, let me know.
Of course. We are not asking you to solve
no, of course.
every problem.
Yeah.
But Cylleneus is very powerful, and so this was a curiosity. So thank you very much for that. Okay, so thank you very much. Now our time, unfortunately, is over. So thank you very much for your contribution, for your also reference materials. And okay, so next week we have another session with Eleni. Eleni Bonte today is with us in StreamYard, and she will present next week on textual analysis. I don't know if Eleni wants to add something, or
I have some. I have built on a little bit on what I showed you last year, so there will be an additional component just to keep you intrigued, so that you join in for next week.
Okay, thank you very much. Okay, so that's it for today. So you have, the video on YouTube, the class outline on GitHub, everything. And so you have to, or at least so you are encouraged to use Cylleneus to experiment with it. So this is important for the students, and we need more data and feedback. So Bill, thank you again. So I wish, and thank you for also to the audience and also the people in StreamYard today. Okay, so I wish you a good night and see you next week for another session of Sunoikisis Digital Classics. Okay, bye.
Bye, thank you.
Thank you.
Bye, thank you guys.